So here we need to find the equation of a plane passing through three non-collinear points. So suppose one plane is given to us on which 3 points are given which are non-collinear, A, B, and C. So they are not on the same straight line, so they are non-collinear points on the same plane. So now here also we have to choose one arbitrary point P, and suppose here is the origin. So this is OA vector, this is OC vector, this is OB vector, and this is OP vector. Now this is AB vector, this is AC vector, and this is obviously AP vector. So now see that here OA vector means the position vector of the point A is given as suppose A vector. Suppose OA vector is A vector, and OB vector, which is the position vector of the point B, that is given as B vector, and position vector of the point C, which is it is given as C vector, and position vector of the point P, that is given as R vector. So then from here we can find the normal vector to the plane, means the vector which is perpendicular to the plane. So n vector will be along, we can say this is AB cross AC. N vector can be taken as AB cross AC, means the cross product of AB vector and AC vector. And AP vector, so now AP vector lies on the plane. AP vector lies on the plane. And so we can say that, so AP vector should be perpendicular to the normal vector to the plane, which is n vector. So AP vector is perpendicular to n vector. And therefore we can say that AP vector dot n vector, that should be equal to 0. Now AB vector, that should be obviously OB vector minus OA vector. So OB vector minus OA vector, that is B minus A vector. B vector minus A vector. And similarly, AC vector will be OC vector minus OA vector. So this would be C vector minus A vector. Then now n vector, that will be equal to B vector minus A vector cross C vector minus A vector. And then AP vector, that would be equal to OP vector minus OA vector. So that would be equal to R vector minus A vector. So therefore we can say that therefore the required vector equation of the plane is, let's say this plane is pi1. So therefore the required vector equation of the plane pi1 is given as the required vector equation. So that would be AP vector dot n vector, that should be equal to 0. So it means we can say it will be R vector minus A vector dot product of that with B vector minus A vector cross C vector minus A vector, that should be equal to 0. So this is the required vector equation of the plane pi1. So this we can see that this is called scalar triple product. So now, so here suppose the vector, suppose the point A has coordinates x1, y1, z1, and the coordinates of the point B is x2, y2, z2, and point C is x3, y3, z3, and the coordinates of the arbitrary point P will be obviously x, y, z. So therefore now R vector minus A vector, that will be obviously equal to OP vector minus OA vector. So that will be obviously x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap. Similarly, b vector minus a vector, so that would be equal to ob vector minus oa vector. So that would be equal to x2 minus x1 I cap plus y2 minus y1 j cap, and then plus z2 minus z1 k cap, and c vector minus a vector, that will be equal to OC vector minus OA vector. So OC vector, so this will be x3 minus x1 I cap plus y3 minus y1 j cap plus z3 minus z1 k cap. Therefore, the vector equation of the plane, is actually the scalar triple product. Means it is r vector minus a vector into b vector minus a vector and c vector minus a vector, that is equal to 0. Means we can tell it as the box product or scalar triple product. It means we know that the scalar triple product is written as scalar triple product is given as a vector dot b cross c, that is equal to 0. So we can tell that the scalar triple product of ABC, that will be 0. So it means scalar triple product of ABC, that will be equal to 0. So in this way you can write. Therefore, here also it is written in this form only, this a vector dot b cross c, that is equal to 0. So we can write it as in the box product form. So it is called scalar triple product, or it is called box product of the three vectors. So now, so therefore the Cartesian form, the Cartesian equation of the plane will be equal to the determinant of r minus a, so that is x minus x1, means the components of a vector we have to write first in the first row, and the components of b vector we need to find in the second row, and components of c vector we need to write in the third row. So here the a vector is this r minus a, so r vector minus a vector we have already found it, which is this one. So therefore, and components of b minus a are these, and components of c vector minus a vector is this one. So the Cartesian equation of this plane will be the determinant of x minus x1, y minus y1, z minus z1, and this is x2 minus x1, y2 minus y1, z2 minus z1, and this is x3 minus x1, y3 minus y1, and z3 minus z1. So that should be equal to 0. So this is the required Cartesian equation of the plane, which passes through the three given non-collinear points, which passes through the three non-collinear points, which are x1 comma y1 comma z1, and x2 comma y2 comma z2, and x3 comma y3 comma z3. So we can understand this by some by one solved example. Suppose here one example is there. Suppose it is asked to find, suppose it is asked to find the vector equations, find the vector equations of the plane passing through the points, vector equations of the plane passing through the points R, which is 2, 5, minus 3, and S, which is -2, -3, -2, -3, 5, and T, which is 5, 3, -3. So these are the 3 points on the plane. So these are the 3 non-collinear points, R, S, and T on the plane. The plane R, on this plane, R, S, and T are 3 non-collinear points. So we need to find the equation of this plane by one. We need to find the equation of this plane. So now, therefore, here we can write that the position vector of the point R is suppose A vector. So that will be 2i cap plus 5j cap minus 3k cap. And similarly, B vector is the position vector of the point S, which is OS vector. So that will be minus 2i cap minus 3j cap plus 5k cap. And the position vector of the point T, we can say it as C vector. So that would be C vector, which is OT vector. So that will be 5i cap, then plus 3j cap minus 3k cap. And we need to take one arbitrary point P also. So here that will be, so the position vector of the arbitrary point is always taken as R vector, which is OP vector. So that is xi cap plus yj cap plus zk cap. Since y, the arbitrary point is always taken as x, y, z. Okay, so now, therefore, therefore, the vector equation is R vector minus A vector dot B minus A cross C minus A cross C minus A, that is equal to 0. So now, B vector minus A vector, that we need to find. So that would be equal to minus 2i cap, then minus 3j cap plus 5k cap, then minus 2i cap plus 5j cap minus 3k cap. So that would be equal to minus 2, so that would be minus 4i cap. Then this would be minus 3, minus 5, so that is minus 8j cap. And this will be plus 5 plus 3, that is plus 8k cap. And C minus A vector and C vector minus A vector, so that would be equal to C vector is 5i cap five I cap plus 3j cap minus 3k cap minus A vector, which is 2, 5 and minus 3, so that is 2i cap plus 5j cap minus 3k cap. So that would be equal to 3 3i cap plus 2j cap. No, that is 3i cap minus 2j cap. Sorry, there's something wrong here. 3i cap minus 2j cap. Okay. So this is C vector minus A vector, and B vector minus A vector is this. So now, therefore, the required vector equation Suppose here it is asked to find the vector equation and the Cartesian equation also, and the Cartesian equation of the plane. Cartesian equations of the plane passing through these 3 points. Okay, so therefore the required equation, vector equation is obviously r vector minus a vector dot b minus a cross c minus a, that is equal to 0. So now this will be r vector minus a vector. A vector is 2, 5, 2, 5, and minus 3. 2 I cap plus 5 j cap minus 3 k cap. Then its dot product with the cross product of b minus a, which is minus 4 I cap minus 8 j cap, then plus 8 k cap. Then cross product it with 3 I cap minus 2 j cap. That will be equal to 0. So now we need to find this the cross product of minus 4 I cap minus 8 j cap plus 8 k cap cross 3 I cap minus 2 j cap. So that would be equal to the determinant of I j k, and then we should write the components of this vector first, which is b minus a vector, which is minus 4 minus 8 plus 8, and then we write the components of c minus a, c vector minus a vector, which is 3 minus 2 and 0. So if we expand this determinant along the first row, then we will get I cap into 0 minus of minus 16, so it is plus 16. So that is minus j cap into this is 0 minus 24. Then it will be plus k cap into 4 to the 8, then plus 3 8 the 24. So this would be 16 I cap plus 24 j cap plus 32 k cap. So therefore, the required vector equation of the plane is r vector minus 2 I cap plus 5 j cap minus 3 k cap dot product with this vector, which is 16 I cap plus 24 j cap plus 32 k cap. It should be equal to 0. So this, if we simplify it, then we will get r vector dot 16 I cap so this would be r vector dot 16 I cap plus 24 j cap plus 32 k cap. That will be equal to 2 I cap plus 5 j cap minus 3 k cap. Its dot product with 16 I cap plus 24 j cap plus 32 k cap. Slightly erase this part. It will be plus 32 k cap. Okay. So then this will be equal to, so this value is 216 the 32 plus 24 5 is 120. Then minus 32 into 3, that is 96. So this will be equal to 152 minus 96. So that would be 6. And then 10 is 15. So it is equal to 56. So therefore, the final vector equation of the plane is r vector dot 16 I cap plus 24 j cap plus 32 k cap, that is equal to 56. Or from here, we can take actually 8 as common. So this would be 8 into r vector dot 2 I cap plus 3 j cap plus 4 k cap, that is equal to 7 into 8. 7 8 is 56. So 8 and 8 will cancel. Therefore, the final vector equation of the plane will be r vector dot 2 I cap plus 3 j cap plus 4 k cap that is equal to 7. So this is the answer, and we can write it in the Cartesian form. Therefore, the Cartesian form of the plane will be, Cartesian form is, simply we need to put r vector equals to xi cap plus yj cap plus zk cap. Simply, if you put that, and if you take the dot product of this vector with the r vector, then we will get the Cartesian form. So this will be 2x plus 3y plus 4z. So which is 2x plus 3y plus 4z, that is equal to 7. Okay. And or we can also so this is the answer actually, or we can find the Cartesian form of the equation of the plane in this form also. That will be the determinant of x minus x1, which is the coordinates of the point A, means the coordinates of the point R. So here R is given as 2, 5, minus 3, and the point S is given as minus 2, minus 3, and 5, and T is given as 5, 3, minus 3. Okay. Okay. Yeah. So then, therefore, this we can take it as x1, y1, z1, and this we can take it as x2, y2, z2, and this we can take it as x3, y3, z3. So then we can write the Cartesian form of the equation of the plane which passes through these 3 points, these 3 non-collinear points, as x minus x1, which is x minus 2. So then x, then so it is actually x minus x1 into y minus and y minus y1, z minus z1. So it is, here there is something mistake here. This will be y minus 5, then z plus 3. Then it will be x plus 2 and y plus 3 and z minus 5. And that would be equal to x minus 5, y minus 3, and z plus 3. That is equal to 0. So if we expand this determinant, then also we will get the same answer. So sorry, this will be actually, sorry, this is wrong. Sorry, there is something wrong here. These we need to change. So this will be x2 minus x1. So it is x2 minus x1. So it is, sorry, these are wrong actually. It will be x2 minus x1. So x2 minus x1 is minus 2 minus 2, and y2 minus y1, and then z2 minus z1, and this is x3 minus x1. So it is 5 minus 2, and y3 minus y1, and y2 minus y3 minus y1, and z3 minus z1. So then this will be actually the determinant of x minus 2, y minus 5, and z plus 3. Then this will be minus 4, then minus 8, then 8, then 3, minus 2, and 0. That should be equal to 0. So if we expand this along the first row, if we expand this determinant along the first row, then it will be x minus 2 into minus 8 into 0, 0 minus of minus 16, so it is plus 16. Then minus y minus 5 into, this will be minus 4 into 0, that is 0. Then minus 3 8 is 24. Then plus z plus 3 into, that will be equal to 4 to the 8, 8 plus 3 8 is 24. So 8 minus of minus 8, so it is plus 24. Okay, so that will be equal to 0. So then we will get 16 into x minus 2, 16 into x minus 2, then plus 24 into y minus 5, then plus 32, 8 plus 24 is 32, 32 into z plus 3, that is equal to 0. So then we can take 8 as common. So this will be 3 into x minus 2 plus, no, 8 2s are 16 and 3 8s are 24. This will be 3 into y minus 5, then plus 4 8s are 32. So 4 into z plus 3, that is equal to 0. So therefore this we will get 2x minus 4 plus 3y minus 15 plus 4z plus 12, that is equal to 0. Then we will get 2x plus 3y plus 4z, that is equal to 12. That is minus 12 plus 15 plus 4. So this is 15, 19 minus 12, that is 7. So therefore the answer is 2x plus 3y plus 4z equal to 7. So we can see that in this, by using this formula also, we are obtaining the same answer. Thank you.